2 students. Today I'm going to teach you how to graph exponential functions using transformation tables. So the first one is f of x equals 4 times 2 to the x minus 3. To graph this function, one strategy would be to input just the values -1, 0, and 1 for just the parent function. The parent function would be without this stretch of 4 and without this shift down 3. So the parent function of 2 to the x, if I input -1 in for x, 2 to the negative first power is 1/2. Inputting 0 for x, 2 to the power of 0 is 1. And inputting 1 for x, 2 to the first power is 2. So what I just created is my parent function table. If this were a base of 3, I would have 1/3, 1, and 3. Or a base of 7, I'd have 1/7, 1, and 7. But it's a base of 2, so my parent function table is 1/2, 1, 2. Now I'm going to apply my 2 transformations, I'm going to use a different color here, to this table. So I have times 4 first. I'm just going to go in order here. A stretch of 4 multiplies all my y values by 4. So times 4, times 4, times 4. A shift down 3 takes those y values that were stretched by 4 and shifts them down 3. So I'm going to take these stretched y values and I'm going to subtract 3. 2 minus 3, 4 minus 3, and 8 minus 3. These 3 points, -1, -1, 0, 1, and 1, 5, are my points on my exponential growth function. So I'm going to plot them, and plot them. Here's the shape of my exponential growth. I'm going to also input my asymptote. I know the whole function shifted down 3. So that exponential growth function approaches -3, my asymptote. And that's it. Just graphed an exponential growth function. Here's an exponential decay. F of x equals -1/2 to the x plus 4 minus 2. So again, I'm going to use my parent function table, -1, 0, and 1. The parent function does not have this reflection, does not have a shift left 4, and does not have a shift down 2. So there's my parent function, 1/2 to the x. 1/2 to the negative first. It's the reciprocal of 1/2, and so that's 2. 1/2 to the negative first is 2. 1/2 to the power of 0, 1. Anything to the power of 0 is 1. 1/2 to the first power, 1/2. So if this exponential decay were 1/3, I would have 3, 1, 1/3. Or 1/4, 4, 1, 1/4. But it's 1/2. So 2, 1, 1/2. So this is my parent function table. Now I'm going to apply 3 transformations to this table. Use a different color. So this is a reflection over the x-axis. I'm going to multiply all my y values, multiply by -1. So -2, -1, -1/2. My next shift is a shift left 4. Moving to the left on a graph subtracts x values. Moving to the left subtracts x values. So it says +4, but moving to the left, I'm subtracting the x values by 4. Subtract 4, subtract 4. And then the last transformation shifts down 2. So I'm going to take my reflected y values and I'm going to subtract 2 to move them down 2. Down 2. So these 3 points are my reflected decay function. Anytime I have a reflection, before I start putting these points, I always try to imagine what does a decay function that's been reflected look like. A decay function, here's a decay function. If it reflects, this is going to be the shape of my reflected decay function. So now that I have this image in my head, I'm going to plot my 3 points, -5, -4. My second point, -4, -3. And -3, -2.5. I'm going to put my asymptote at -2. And I'm keeping that shape that I had in my mind so I can sketch it in for my completed decay function that's been reflected graph. If you have any questions, let me know. Google it, ask somebody, go to the Lit Center, email me. You can do it. Graph exponential functions.